Hari Om. Hello everyone, I'm Shrees. Welcome back to my channel. Today's video is of class 12 mathematics chapter 5 continuity and differentiability. Continuity and differentiability is the part of calculus which is one of the most important branches of mathematics. In class 11 we learned functions, limits and differentiability of functions and some method to value them, right? But here continuity and differentiability. See, this continuity and differentiability, it's all about functions. Okay, we know functions. We have already learned in 12th standard also. We have learned about functions, right? See, this continuity is nothing but continuous function. Okay, here we know that continuous function means it refers to a function that does not have any breaks or any jumps in the graph. We know that if any function can be drawn as a graph. Right? Here continuous function, in a continuous function, that graph can be drawn without lifting our pencil. Okay? That means there is no jumps or no breaks in the graph. So for example, see here, suppose it's a graph. Okay? If it breaks here, we say at some point it will break, right? Okay, we say this function is not continuous at this point. Okay, so here now let us go through. Mathematically we say here we saying the graph is or function is continuous at a point, at some point, or continuous at a continuous on some interval. Okay, or continuous in real life. So now let us study how a function is continuous at a point. Okay, what is a continuous at a function is continuous at a point. Continuous function at a point. So here a function is said to be continuous at x is equal to c. Okay, a function is continuous at x is equal to c if there is no breaks. Okay, there is no breaks in the graph of the given function f of x, given function f of x, then at the point c f of c. Okay, don't be confused, don't worry, it's very easy chapter. See, after first example itself you will understand it very quickly. Okay, so just understand what is the definition. See, here we will study function continuous function at some point, continuous function on some interval, continuous function in real line. Okay, so how we determine if the given function is continuous at a point and continuous at some interval or in real line. So now let's see. Here a function f of x is said to be continuous at x is equal to c if there is no breaks in the graph of the function f of x at this point. Okay, here at this point means it is the ordered pair. Okay, here c is x coordinate and it is y coordinate value. See here, let us take one example. Okay, f of x is equal to 1 by x. Okay, so f of x is equal to, we know that f of x is equal to 1 by x, graphs will be like this. Okay, it's a rough sketch. Okay, so here see some point, see, take x is equal to 0. See, when we take x is equal to 0, this function is not defined, right? 1 by 0, it's not defined. So here at x is equal to 0, this function is not defined, right? So this graph will break here, right? A hole will be here because it is not defined at that point. Okay, here when x is equal to 0, this graph is not defined. Okay, this function is not defined. So this graph will break here, again starting from here. So it breaks here. Therefore we say here this function is not continuous at x is equal to 0. Okay, now you might have understood what is a continuous function, right? So continuous function at a point, that is a function f of x is said to be continuous at x is equal to c if there is no breaks or no hole in the graph of the function, given function at this point. See, what is this point? 0, 1 by 0, right? When x is equal to 0, so when x is equal to 0, 1 by 0, right? It is not defined, therefore here we got a break, okay? A break in the graph, okay? So next is, now you understood, right? So what is a function? When a function is continuous at a point. Now next we will study a continuous function on some interval, okay? Now let's say when a function is continuous in an interval, okay? Suppose an interval 0 to 1, okay? So a function f of x is said to be continuous in an interval 0 to 1 if there is no breaks in the graph of the given function in the entire interval range. That means here the function f of x should be continuous at all the points in the interval. Okay, see here we know that many points are there. So some points we will take 0.1, 0.1 or 0.1, 0.2, etc. 0.99. All the points are including here, right? So this function should be continuous at all these points. Then we say the function is continuous in the interval 0 to 1. Now we are going through definition of, that is mathematical definition of continuity at a point. Okay, it's very important definition. And say we have to determine, right, how to determine a given function is continuous or not. Okay, so here continuity at a point. A function f of x is said to be continuous at x is equal to a if left hand limit at x is equal to a that should be equal to right hand limit at x is equal to a, that should be equal to value of the function. Value of the function at x is equal to a. Okay, that is limit x tends to a minus. Here a minus means left hand limit. Okay, f of x that is equal to limit x tends to a plus f of x that is equal to limit x tends to a f of a. That is, here we can write value of the function means direct substituting x is equal to a. Okay, so that is f of a. So in this case we say given function is continuous at x is equal to a. See here, otherwise see you can define this function, this continuous function. A function f of x is said to be continuous at x is equal to a, and if limit x tends to a f of x exists and limit x tends to a f of x is equal to f of a, then the function is continuous. Okay, so here see, I hope that you understood what is this right hand limit, left hand limit. You already learned in 11th standard limit chapter, right? So here left hand limit of at x is equal to a. So what is the left hand limit? See here, if it is a point 0, that is left of 0. Point 0, then what is left of 0? That is the value approaching to 0 but not 0, approaching to 0 but left of 0. That is less than 0. That is minus 0 point, okay, 0.0001 like that. Here right of 0 means 0.0001 like that. Okay, that is not 0, not equal to 0 but approaching to nearby 0. Okay, very close to 0. So here that is x tends to a minus means here the value is left of 0. Okay, and limit x tends to a plus, that is values after 0, that is greater than 0. That should be is equal to f of a. It is the definition of continuous function. Or see, we can write a function, that is, I will write the equation, limit extends to a, if limit extends to a f of x exists and limit extends to a f of x, that should be is equal to f of a. Okay, see, it is very important. It's also very important. Okay, see how to determine given function is continuous function. See, we have to equate this one, means we have to find this one. If it is equal, then we say given function is continuous. Limit extends to a f of x is equal to f of a. Now let's go through some examples. Check the continuity of the function f given by f of x is equal to 2x plus 3 at x is equal to 1. Very easy question. Here given function is f of x is equal to 2x plus 3. We have to check whether the limit extends to 1 f of x exists. It exists, right? See, just put x is equal to 1, you will get a value, right? So we can write limit extends to 1 f of x. We have to find it. That is, substitute the value 2 into 1 plus 3, that is equal to 6. Okay. So here what is f of 1? F of 1, substitute x is equal to 1, that is 2 into 1 plus 3, that is equal to also 6. So here we have got limit x tends to 1 f of x, that is equal to f of 1. Right? That is the definition. Limit extends to a, f of x is equal to f of a. Okay, if limit extends to a, f of x is equal to f of a, then given function is continuous, right? Limit extends to a, f of x is equal to f of a, then given function is continuous at x is equal to a. So here given function is continuous at x is equal to 1 because we have got limit extends to 1 f of x is equal to f of 1. Second example, let f from R to R be defined by f of x is equal to greatest integer function where it denotes the greatest integer less than or equal to x is f continuous at x is equal to 0. Okay, before determining function is continuous, we should understand what is the greatest integer function, how it is defined. The greatest integer of x is, suppose x is equal to 5.6. Okay, that is greatest integer value of 5.6 is, see, the larger number less than 5.6. Larger number larger integer less than 5.6 is nothing but 5. Okay, so 5.6 greatest integer value of 5.6 is 5. Minus 1.8. Here larger number but less than minus 1.8, that is equal to minus 2. Okay, this minus 2 is less than this one, right? Okay, so here, it is the only integer. Okay, greatest integer function. So here now come to our definition. We have to determine given function is continuous. Okay, so here what is our definition? Limit x tends to 0 minus f of x, that is equal to limit x tends to 0 plus f of x is equal to f of 0. We should get this one, right? Then we say given function is continuous. Okay, so for that we have to find left hand limit, right hand limit, then value of the function. If first of all we have to check whether limit extends to 0 f of x exists. Okay, for that this left hand limit and right hand limit. Okay, see, if you have any doubts in limit of the function, you go through the limit chapter, okay, in class 11. So here, see, we know that, see, suppose it's a point 0. Okay, we have to check whether f is continuous at x is equal to 0 or not, right? So at point x is equal to 0, here left hand limit means when x approaches to 0, x is close to 0 but less than 0. Less than 0 means here minus 0.99 something, greater than 0 means 0.0001 something. Okay. So here, so for that we have to find left hand limit and right hand limit. Okay. Now limit x tends to 0 minus f of x. Here x tends to 0 minus means the x value is very close to 0 but less than 0. Okay, left of 0. Okay, then f of x is equal to, see here, limit x tends to, or here we take, see, the values are less than 0, right? Less than 0 means 0 minus some value. Okay. So here it will be minus values, right? Less than 0 means it will be minus. So we write it as h tends to 0. We take that value h. Okay. That is greatest integer 0 minus h. Okay. So 0 minus h means that value is negative. Okay. That means minus 0 point something. Okay. 0 minus a small value. Okay, h is a small value. Okay, so that is equal to, see here, we know that here it's a small value, h is a small value, and this greatest integer value of here minus value, right? Because 0 minus something, okay, 0 minus a small value, that will be minus 0 point something, right? Minus 0 point something. So what is the greatest integer of minus 0? See here, greatest integer of minus 0.9. The larger number, larger integer less than minus 0.9 is nothing but minus 1, right? That is larger number but less than minus 0.9. Okay, that is minus 1. So here, what is the greatest integer of this value? See, it is nothing but 0 minus a small value, that is minus 0 point something, anything, it's minus 0.99, whatever. Okay, so what is its greatest integer? That is nothing but minus 1. Okay, so here we have taken h as a small value. Okay, then next, limit x tends to 0 plus f of x is equal to, here 0 plus means x is very close to 0 but greater than 0. Okay, that is approaching to 0, right of 0. Okay, close to 0, greater than 0, that is right of 0. That means it will be positive. Okay, so here we take limit h tends to 0, 0 plus h. Okay, take h is a small value, 0 plus h, it is very close to 0, that is right of 0. So it will be a positive value, right? That means suppose it will be 0.01 or 0.02 or 0.001. Okay, whatever. So what is the greatest integer value of 0.001? 0, right? That is 0.01 is nothing but, see, larger integer less than 0.01. That is 0 itself, right? So here the value is 0. Okay, here it is minus 1, here 0. See, we have got left hand limit and right hand limit are different, right? So therefore we say limit x tends to 0, limit x tends to 0, f of x does not exist. Does not exist. Therefore, given function is not continuous at x is equal to 0. Okay, given function, that is greatest integer function, is not continuous at x is equal to 0. Okay. Discuss the continuity of the function f given by f of x is equal to modulus of x at x is equal to 0. It's also a very important question. So first of all, let's write the definition of modulus function. Modulus function f of x, that is equal to minus x, okay, modulus x is equal to minus x when x less than 0. F of x is equal to x when x greater than or equal to 0. Okay, it is the definition of modulus function. Okay, f of x is equal to, that is modulus x is equal to minus x when x less than 0. Okay, and f of x is equal to x when x greater than or equal to 0. So here let's find left hand limit of the function and right hand limit of the function. Okay, that is limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus means less than 0, right? 0 minus, that is left of 0. In left of 0, that numbers will be less than 0, right? That will be minus. Okay, so that means x less than 0. When x less than 0, function is minus x. So minus x, that is equal to, substitute 0 value. Okay, substitute 0 here, what you will get? 0, right? Next, limit h tends to 0 plus f of x, that is equal to limit x tends to 0 plus, here 0 plus means right of 0, in right of 0 the value is greater than 0, right? So when x is greater than 0, function is x, that is equal to, here also substitute x is equal to 0, so we will get 0. Okay, so we have got limit x tends to 0 minus f of x, that is equal to 0, and limit x tends to 0 plus f of x, that is equal to 0. Limit x tends to 0 minus f of x, that is equal to limit x tends to 0 plus f of x. Now we have got these two are same, okay, and therefore limit x tends to 0 f of x exists. Then what is the value of the function? Okay, limit x tends to 0 f of x exists, okay, because here these two are equal. And what is f of 0? Value of the function, okay, value of the function and x is equal to 0. F of x is equal to modulus x and value of the function f of 0, substitute modulus of 0, that is 0, right? Or here we can see when x is greater than or equal to 0, when x is equal to 0, f of x is equal to x, therefore f of 0 is equal to 0. So we have got limit x tends to 0 minus f of x is equal to limit x tends to 0 f of 0 plus f of x, that is equal to f of 0. Okay, by the definition we say given function is continuous at x is equal to 0. Next example, consider the function f of x is equal to x square minus x minus 6 divided by x plus 2 when x not equal to minus 2. F of x is equal to minus 5 when x is equal to minus 2. See, very important question, 2009 question, okay. So here, first question is, what is the value of f of minus 2? What is the value of f of minus 2? Very easy question. See here, it is given f of x is equal to minus 5 when x is equal to minus 2. When x is equal to minus 2, the value is minus 5, right? That means when you substitute x is equal to minus 2, the value is minus 5, right? So directly we can write first answer, f of minus 2 is equal to minus 5. That's all. So second question, we have to check whether given function is continuous or not at x is equal to minus 2. See, here we need not to find left hand limit and right hand limit. Okay, here directly we can write limit x tends to minus 2 f of x. Okay, we will find limit x tends to minus 2 f of x, that is equal to, here see left of minus 2, that is also minus, right of minus 2, some values are there minus, right? So here no need to find the left hand limit and right hand limit. Directly we can go to limit x tends to minus 2 f of x. Okay, so limit x tends to minus 2 f of x is equal to limit x tends to minus 2, here x square minus x minus 6 divided by x plus 2. See, before coming to this chapter, please you must go through the chapter limits, okay? Then come to here. Then x square minus x divided by x plus 2. See, how to find the limit? See, if you substitute x values here, what you will get? You will get 0 by 0 form, right? See, if you get 0 by 0 form, you have to apply some other method or you have to factorize, okay? Then cancel. Then find the limit, okay? So here, we know this numerator can be written as x minus 3 into x plus 2, right? Minus 3 plus 2 minus 1. Minus 3 into 2 minus 6. Okay. Divided by x plus 2. So that this x plus 2 will be cancelled. Right? X plus 2 is cancelled. See, don't forget to write the limit. Okay. Limit x tends to minus 2. That is equal to, here x plus 2 cancelled. X plus 2 cancelled. So we have got limit x tends to minus 2 x minus 3. Now you substitute x is equal to minus 2. Okay, that is, substitute x is equal to minus 2, what you will get? Minus 2 minus 3 is minus 5. Minus 5, right? So, limit x tends to minus 2, f of x exists and its value is minus 5. So, to check continuous function, what is our definition? Limit x tends to minus 2, f of x should be equal to value of the function, that is f of minus 2. What is f of minus 2? Minus 5. We have got the same, right? So we can write limit x tends to minus 2 f of x, that is equal to f of minus 2. Okay, it is the definition of the continuous function at a point, right? So limit, here we have got limit x tends to minus 2 f of x, that is equal to f of minus 2. Therefore, given function is continuous at x is equal to minus 2. F is continuous. Therefore, f is continuous at x is equal to minus 2. Look at next question. Is the function defined by f of x is equal to x square minus sin x plus 5 continuous at x is equal to pi? So here let's find limit x tends to pi. Okay, x tends to pi f of x, that is equal to limit x tends to pi. Here function is x square minus sin x plus 5. Okay, directly substitute x is equal to pi. Okay, see, when you substituting, if you are getting 0 by 0 form, then you have to apply some other method. Okay, but here, see, just substitute x is equal to pi, what you will get? Limit, okay, pi x square, that is pi square minus sin pi. Sin pi is 0, right? Sin pi is 0, cos pi is minus 1. Sin pi is 0 plus 5. Okay, so pi square plus 5. So next we have to find, okay, we have to check whether given function is continuous or not, or right? So for that we need to find value of the function, that is f of pi. F of pi. What is f of pi? F of x is this one. So substitute x is equal to pi in the function, given function, that is pi square minus sin pi plus 5, that is equal to pi square minus 0 plus 5, pi square plus 5. Okay, so we have got f of pi is equal to pi square plus 5. Okay, so by the definition of continuous function, limit x tends to pi, here we have got, see, if limit, what is our continuous function definition? If limit x tends to a, f of x should be equal to f of a, right? Then we say given function is continuous, otherwise it is discontinuous. Okay, so here we have got limit x tends to pi f of x, that is equal to f of pi, right? Limit x tends to pi f of x, that is equal to f of pi Hence, given function is f is continuous at x is equal to pi. Okay.